and good afternoon. CTS265, Section 840 students for the Fall 2016 semester at Anne Arundel Community College. This is the CCNP route course, and this morning's video tutorial is going to be on Discovery Activity number 16 in our Cisco Learning Labs curriculum. And we're going to be focusing now, we talked initially in Discovery 15 on redistribution and sort of redistributing everything. And now what we're going to focus on is how to manipulate via access lists, distribute lists, and prefix lists, how we can go ahead and actually take further control over our redistribution. So here is our topology. So let's go ahead, and the first thing we're being asked to do is to configure redistribution from OSPF, right over here on the left, into EIGRP. And we want to filter some routes out. So specifically the 10, 10, 21, 22, 23, and 24. You can see we've got some additional loopbacks down here that are 172.16. So let's hop on to router 1 and let's see what we currently have on router 1 here. So let's get into global config and say do show run section EIGRP. So there's the current EIGRP setup that we have. And let's say do show run section OSPF. Are we running OSPF on here as well? And we're doing some mutual redistribution as it is. So we're going to first do an ACL. Right now, remember, you can use ACLs. You can also use prefix lists. So remember that the ACL is not a natural route filter. ACLs are for packet filtering, not for route. Well, I mean, you can use them for route filtering, but that's not what their original / intended purpose was. ACLs were simply packet filters, right? And then network engineers needed more control over routing information, and so ACLs were adapted to become route filters. And so we're using those two things, the ACL and the prefix list, and those are used with a distribute list in order to allow us to take more control over the redistribution that we're doing. Now remember, a distribute list really isn't a list at all. It's just simply a command that we use when we're performing redistribution in order to apply access lists and prefix lists to filter information that's being redistributed. Because again, think back to Discovery Activity 15, where we were simply just saying, you know, redistribute OSPF, process ID, whatever, into EIGRP. And then everything from that OSPF process got redistributed into EIGRP, and vice versa. When we said redistribute from EIGRP into OSPF, everything out of that OSPF domain was redistributed into OSPF. I'm sorry, everything from that EIGRP domain was redistributed into OSPF. We weren't selectively picking certain prefixes off to say, redistribute this one, but don't redistribute this one. It was just all or nothing. So now we take that next logical step and we take a look at how do we pick off certain prefixes. So here's what we're going to say. We're just going to create a numbered access list, right? So I say access list, I'm sorry, standard numbered access list. So access list 1, and we do not want to allow the 10, 10, 21, 22, 23, and 24 to be redistributed. So there's a number of ways we could do this. We could say deny these and then allow anything else, or we could say allow these and let the implicit deny at the end take over and deny everything else. So we're going to approach it from this perspective here. So 10, 10, what are we doing? 21.0, 0.0.0.255, because they're /24s. So we're going to deny the 21. We're going to deny the 22. Now remember, what I'm doing right now, this does nothing until it gets applied with the distribute list. So all of these statements here, if I was to look at the configuration, if I don't apply this access list to something, it doesn't take effect. I mean, these are just basically statements that I'm making in global config, and it's until and when I apply it that it takes effect, or not until and when I apply it that it takes effect. So now if I were to say router EIGRP 100, and let's do show run section EIGRP. So there's the redistribute OSPF10 metric command, right? So we already have, and so there's kind of a disconnect here from the reading and the lab. There's a minor disconnect. All the redistribution is being done already. It's done. So here's my redistribute OSPF10 metric command. Again, I'm redistributing from OSPF process ID 10 everything in OSPF process ID 10 on this ABR, and I'm assigning it the metric values here so that when it goes into EIGRP process ID or autonomous system 100, these are the metric values that it has in order to calculate the composite metric value. So again, we're apples and oranges. So we have to say when we're sending or injecting OSPF routing information into EIGRP to make it apples to apples, we give those OSPF routes an EIGRP set of composite metrics so that EIGRP looks at those and says, oh, hey, those must be EIGRP routes. They've got the metric information that I need, so we're going to go ahead and take that information. So again, we're going from OSPF into EIGRP. So over here on router 2, when I say show IP route, and actually let's trim it down here, show IP route EIGRP, you can see there's the 21, the 22, the 23, and the 24 as DEX, EIGRP, and that D stands for dual, the diffusing update algorithm. But I also see all my 172.16s, the 11, the 12, the 21, 22, 23, and 24. All of these guys, 21, 22, 23, 24, there's the 11 and there's the 12, the transit links, right? So all I'm saying is I want to remove the 10, 10, 21, 22, and 23, and 24. I do not want those to be advertised into EIGRP. So how do I limit or filter what's being redistributed? And it's very, very simple. We simply apply after we've redistributed, right? And here the disconnect was that when you're following the activity, it immediately has you do the distribute list. Well, again, that's assuming I've already applied or entered the redistribute command. So I'm going to say distribute list, and what does the distribute list refer to? Well, the distribute list should be referring to the ACL that I created. And here you can see, you can use a standard ACL. We can use a named ACL. We can use standard and extended. We can use named, standard, and extended. I can use a prefix list, right? I can use a route map with my distribute list. Now, this is, again, this is OSPF v2. So OSPF for IPv4. When you look at OSPF v3, you can no longer use ACLs. You can only use prefix lists. And this is true for RIP-NG. It's true for EIGRP for IPv6. And it's true for OSPF v3. So they've kind of, Cisco going forward has straightened things out to where you can no longer use the ACL. You can only use the prefix list. Okay, so we're going to go ahead and say distribute list 1, but it's not distribute list number 1. It's distribute list referring to the ACL I created, which was ACL 1, the numbered ACL, standard ACL 1. And actually, you know what I just realized? So I've got a mistake in the ACL. And if you haven't picked up on it already, let's come back to it. Let's do it wrong, and then we'll fix it and do it right. So distribute list 1, and in what direction? In or out? Well, remember, it's out from OSPF, because that's what I'm trying to limit here, or trying to filter. I'm trying to filter the outbound redistribution from OSPF. That's why it's in the outbound direction. So 1 OSPF, and the process ID is 10. So I hit enter. Let's come back over to router 2 and let's see what does this look like now. So we've still got that information in there, and what I'm anticipating is gonna happen here There we go. So the resync graceful restart, right? So we've got it. So what do you think we're going to see now? Is it going to be all the information? Is it going to be just the 10s with no 172s? It was going to be just the 172s with no 10s, or because of the mistake in my ACL, is it going to be nothing? Show IP route EIGRP. Why am I seeing nothing? So we'll come back over here to router 1. So here's my ACL. What's wrong with that ACL? Exactly. I denied those 4 networks, but what is at the end of every ACL? An implicit deny for everything else. So again, my approach is I'm saying I don't want 21, I don't want 22, I don't want 23, and I don't want 24. Well, the last thing I need to say then is, what do I want? I want everything else other than those 4 routes. So if we were to say do show access list 1, you can see we've got 10, 20, 30, and 40. What if I were to say access list 1 permit any, and then say do show access list 1? It dropped it in there down at the 50 spot, which is where we wanted it. Now, if that would have showed up before number 10, we would be in trouble, because then that wouldn't solve our problem of denying those networks. So now we've changed the ACL. Let's come over to router 2. And now we get what we expect to see. So again, using the ACL, it's very simple. It's certainly not difficult to do, but the purist is going to tell you that you are doing route filtering here. We are filtering routing information. We are not filtering packets. So you should be using a prefix list. That's, again, the purist is going to tell you, use a prefix list. That is what you should be using. And so that's a nice segue into our next setup, which is for the IPv6. No, it's not the IPv6 information. I think we're doing EIGRP. Okay, so we're doing EIGRP into OSPF now, but we're going to be using a prefix list. So we just did OSPF into EIGRP. Now we're going to do the other direction. We're going to go EIGRP into OSPF, but we're going to do it using a prefix list. So if you're following along, we're on step 3, and it says add a prefix list to the distribute list to advertise all matching prefixes into OSPF in the range from 172.16.00 to /16 to /24. Now, an access list, standard or extended with EIGRP and OSPF, you cannot do this. You cannot do this. Now, if we're looking at BGP, there is a very convoluted way to manipulate an extended ACL in order to try to define ranges, right? But it's not as easy as it is with the prefix list. So we want to use the prefix list. So let's come over to router 4, get as far away from the EIGRP domain as we can, and we're going to say show IP route EIGRP. Sorry, show IP route OSPF, because we are in OSPF. And there are all the OE2s that we see. All that information, right? The 10, 10, 11, 12, 13, 14. And then the 172.16, 13, which is a transit link. But then we've got 41, 42. Well, we've got these 41, and then a 42, another 42, and another 42, which are 3/26s. So they kind of mixed it up on us there. So, and actually looking at what they're asking here, the reason they're showing this, right, is because we have to match everything from a /16 to a /24. So, and that's what we're permitting to be allowed in. What we're not permitting are these /26s. So these are what is going to go away. We should lose those last 3 there. So let's get back onto router 1. And let's set this up. So do show run section. We're going from EIGRP into OSPF. And so there we are. We already have down here, sorry, let's make sure I get the right section. We looked at that above section earlier. So there's the section for OSPF, right? Redistribute from EIGRP autonomous system 100. So everything right now is being redistributed in. So we want to scope it, limit it, filter what is being allowed from EIGRP into OSPF. And you can see we've got that critical subnets command there. Don't forget that, like I always do. So we need a prefix list. So we're going to say IP prefix list, and we'll just call this EIGRP underscore into underscore OSPF. And sequence number, I always like to start at 5. So again, this is going to be super, super simple with a prefix list. So we're going to permit 172.16.0.0 slash 16 less than or equal to 24. And so what does that mean? That means that the first 16 bits must match. That's what that slash 16 means, is that the first 16 bits, so everything has to be 172.16 dot whatever dot whatever from a slash 16, whoops, the pen's kind of dying on me, to a slash 24 inclusive. And you'll see that because we saw that there's a slash 24, so it's inclusive. So what this is not going to match is anything with a subnet mask of a slash 15 or lower, all the way down to the slash 0, or anything greater than a slash 24. So a slash 25 or a slash 26, like we saw earlier, right? We see those 3 26s will not be permitted. And just like the ACL and just like the route map, what is at the end of every prefix list? Exactly, an implicit deny any. So that is all I need. That single statement right there is all I need. If I were to try to do this with an ACL, and I should say with a single ACL, I couldn't do it. What would I have to do? And again, this is not what you want to do, because here's the alternative. I could say access list, and what are we going to do here? Well, I could do different numbers. So we'll say access list 99, permit 172.16.0.0, and then say 0.0.0. So a slash 16 would be that. Then I would say, well, I want a slash 17 too. So then it would be .254.255. And is that right? Let's see, so 17 would be with the 1. Yeah, 254, 255. So then I want a slash 18, which would be 252. And then I want a slash 19, which would be 248. And then I want a slash 20, which is going to be 240. And then I want a slash 21, which would be 224. I'm trying to do this in my head. 224. And then I want a slash 22, which would be 192, I believe. I may be missing one here. But you get the idea, right? Slash 23 is going to be 128. And then I want a slash 24. So do you want to have to type in all of that or this single command? Yeah, I mean, not much of a rhetorical question there. But it does. It proves, it goes to prove the point that the prefix list is far more scalable than an ACL. And this is a great opportunity to discuss why and the use case as to when the prefix list is far more scalable. So now let's get into that router. We're going EIGRP into OSPF process ID 10. And again, we already have the redistribute statement is already there. So now what I need to do is I need to scope it down with the distribute list. So distribute list, and remember we do the question mark, we want to say prefix list, and then the name of my prefix list, which is EIGRP underscore into underscore OSPF. and then we'll do another question mark, and you'll see, is it in or out? Well, remember, this is from EIGRP, so out of the EIGRP 100 domain, or the autonomous system, out of, and then the protocol, and you can see EIGRP, and autonomous system number was 100. So again, distribute list prefix EIGRP into OSPF, out EIGRP 100. So from out of the EIGRP domain, that is where I'm applying this distribute list. So all the information being redistributed from out of EIGRP Autonomous System 100, I am going to filter with my distribute list as it goes into OSPF. And so let's go ahead now, come over here to router 4, and what should we see? Should we see any of those /26s, those 3 /26s at the bottom? We should not. And what else do we not see? Because remember, we only permitted 172.16.0.0/16 up to /24 inclusive. So we will lose everything that does not meet that criteria that's being redistributed, which means that guy, that guy, that guy, this guy. Down here's our 172.16s. The 12 stays, the 13 stays, the 41 stays, but we lose that, that, and that. And again, the use case for this, it could be a company merger. It could be you're interfacing within your own company, and you've got, maybe one group was siloed off and they were using EIGRP, and another group was using OSPF, and now those two groups need to merge. And so this is a great example of how you would go through, and once you have done the redistribution of everything, to now go through and pick off certain prefixes for further filtering, right? Or I shouldn't say for further filtering, but for filtering. Because again, if you redistribute, it's sort of like, the wild, wild west. If you just say redistribute from EIGRP into OSPF and OSPF into EIGRP, everything goes, right? All those routes are going to go. If you want to filter them, you do the distribute list. All right, so now let's take a look. Again, the book does a phenomenal job by showing you some commands to run against the prefix lists to see information. And I'm not going to do it on router 4. I'm going to do it on router 1, where my prefix list is defined. So if I was to say show IP prefix list detail, let's see if we're matching anything. And again, this is a great way. Sure, you can look at the routing table, but this is also a great way, and I didn't want to do that off the bat. We want to come back here. Hold on. Back to router 1. This is a great way to be able to see, okay, here's my prefix list. There's the name of my prefix list, right? IP prefix list, EIGRP into OSPF. Count is 1. Range of entries is 1. Because again, we have that single range, the 172.16.0.0. Sequences, there's only 5. There's the statement, and there is the hit count, right? Hit count of 2. Which means this ACL has had 2 hits, which is exactly what we want. And so every time we do some sort of a new redistribution, the counter will increase by 2 because we have 2, and I'm actually reading this right off the sheet. There's 2 networks on R2 that match the prefix list, the 172.16.41 and the 13. And so that's why we end up seeing the 2, okay? And each time we do a redistribution off of router 2, that's what we're going to see. Because again, remember, this is what is coming off of, or what's going through our filter. So let's do this, right? We'll go ahead, we'll cruise over here to router 2. Remember, router 2 is over here. It's got this information here. So let me add in a new redistribute command on router 2. So I'm going to say, go into global config, interface loopback 99, and we're going to say IP address 172. Or actually, here we'll make it a 192. 192.168.168.168. And we're going to make it a /24. Now remember, we are redistributing connected subnets. Do show run section OSPF Sorry, get over the. Do show run section EIGRP. Trying to think this through here. Yeah, so I need my network statement in here. So router EIGRP 100, which is where we're redistributing from. We're going to say network 192.168.168.0.0.0.0.255. So now I've got that network in EIGRP. If I come over here to router 1 and I say show IP route EIGRP, we should see our 192.168.168. So there it is. It's in EIGRP AS100. It's being redistributed off of router 1 now. Show run section OSPF. Because we've got this distribute list. Where is it? So here we are in OSPF. We're redistributing into EIGRP from EIGRP 100 into OSPF, and we've applied the distribute list. So I've got a new route has been added. So when I say show IP prefix list detail, we should see the hit count should go up for us at some point. I don't know if I need to clear the EIGRP process on here. Let's do this. Clear IP EIGRP, and we can get away with 100. Whoops. Neighbors, and we want router 2 soft. And let's see if that assists us. Show IP prefix list detail. So the hit count is, oh, I'm sorry. The hit count is at 2 because that's what's being allowed. I apologize. I'm still thinking of the first scenario where we were denying. So here, let me simply do this real quickly. We're going to add something in that is being permitted so that we can see the hit count go up. I was in the deny mode there. Interface loopback 100, IP address 172.16.16.16, and we're going to make this a slash. We'll just go /24. Keep it simple, right? And then we're going to get into router EIGRP 100, and we're going to say network 172.16.16.0.0.0.255. All right, so that should be redistributed now. And there we go. The hit count is 3 because we have a third network that now qualifies. There we go. I apologize. I tell you what, sometimes you get turned around in redistribution and you just end up going the wrong direction, down the wrong rabbit hole. So there it is. The hit count increments to 3. All right, well, this is going to wrap up the discovery activity 16. Again, I love the way these activities kind of like take an inductive approach. And we started small. We did redistribution with everything. And now we look at Discovery 16, and it's like, hey, okay, we're already doing the redistribution, but now we want to scope things down. We don't want everything to be advertised out. How do I do that? And this gives you a great opportunity of seeing the ACL and the prefix list used together. And now Discovery 17, which is going to be the next activity, now we're going to go ahead and we're going to use route maps in order to do the filtering. All right, guys, thanks for watching, and I'll see you this evening at 6 o'clock.